Hi students, welcome to this course, PLC Automation, an introduction to programmable logic controller. I am Professor Yao. Typical continuous process control curve. The keywords: the electromechanical system, a feedback loop, a position in degrees. In actual practice, undershoots or overshoots, dampered response, not perfect but the best. To illustrate some of the possible system response curve for process control system, we will use the electromechanical system as shown in Figure 23.3. Figure 23.3 shows a control system with feedback loop, which can be PID. The dial is set to a position in degrees, and the output devices is to take the positions set on the dial. This picture shows the position indicator with PID control. The output is to follow quickly and accurately any change from one dial setting to another. Furthermore, the output position should not drift out of position over a period of time. Another factor is that the indicator can have two different weights depending on the application. These are 5 pounds and 20 pounds. Obviously, the output drive will tend to operate more slowly for 20 pounds than for 5 pounds. Unless a proper PID control is set up to compensate for weight difference. For illustration, we very quickly turn the dial from 0 degrees to 108 degrees at 3 seconds. After time base 0. Ideally, the position indicator should instantaneously reach 108 degrees as shown in Figure 23.4. Obviously, this does not happen in actual practice. Figure 23.5 shows 5 possible curves for different types of control. Figure 23.5a is an idealized movement, but takes 4 seconds. This picture shows ideal position control positioning curve. This picture shows an idealized movement. Figure 23.5b undershoot or overshoot the mask. Figure 23.5c shows cyclic response and reaches an angular point near the set position, but oscillates for a few seconds before reaching the proper position. Figure 23.5d shows damped response and reaches the new position but continuously oscillate above the final setting. This picture shows undershoots or overshoots. This picture shows oscillate for a few seconds. This picture shows damped response. Figure 23.5e reaches the new position but continuously oscillates above the final setting. None of these curves show an acceptable control characteristics for accurate and prompt operation. By comparison, PID control obtains the most ideal response possible. Not perfect, but the best we can do. And accurate for this control is shown in figure 23.6. This picture shows continuously oscillate. This picture shows ideal PID position control. PID modules. The keywords: equipped with, time-consuming operation, the proportional circuits, the integral circuit, the derivative circuit, the input transducer. PLC often comes equipped with PID modules used to process data obtained by feedback circuitry. Most such modules contain their own microprocessor. Since the algorithms need to generate the PID functions are rather complex, the PID microprocessors relieves the CPU of having to carry out this time-consuming operation. To understand the PID module, refer to figure 23.7. The PLC sends a set point signal to the PID module. The module is made up of three elements: the proportional circuit, the integral circuit, and the derivative circuit. This picture shows the typical block diagram of PID modules. The proportional circuits creates an output signal proportional to the difference between the measurement taken and the set point entered in the PLC. The integral circuits produce an output proportional to the length and amount of time the error signal is present. The derivative circuits created an output signal proportional to the rate of change of the error signal. The input transducer generates an output signal from the process being controlled and feeds the measured value to the PID module. The difference between the set point coming from the PLC and its measured value coming from the input transducer is the error signal. Some sort of correcting devices, such as a motor control, valve control, or amplifier, takes the error signal and use it to control the correction sent to the process being controlled. Homework: handwriting all keywords and submitting them to Coach Facebook. Just do the online quiz and see you next time.